everybody. So today's lesson is focused on the y-intercept of a line. And I know I've probably hinted at this in class, but the y-intercept of a line, not to overcomplicate it, because that is definitely not what I want, is as simple as where does the line cross the y-axis? That's it. That is what the y-intercept means. So if the equation is in the form y equals mx plus b, the letter b, and that is a standard notation, represents the y-intercept. Now we are going to work as well on having these, grabbing a pencil, sorry guys, on having these equations in this format. And I'm going to practice with you like crazy because it is such a helpful skill to you going forward. But in this format, B represents the y-intercept. So in this equation in your notes, x equals 2y, or x plus 2y equals 7. It's not in that format. So I'm going to give you a little preview, and I'm showing this on purpose, even though it's a preview, because it explains what's going on. Now, in this graph, you also have 2 points. You could figure out the slope very easily with the slope formula based on those 2 points. But let's look at this equation. The equation is x plus 2y equals 7. But really, I want it in this format here. That means I have to isolate y. Now, for a long time, we've been isolating x. We don't want to in these. We want to isolate y. So the rules of solving an equation remain the same. I want to get x away. So instead of a positive x, negative x on both sides. Okay. Now I have 2y equals negative x plus 7. Now I'm purposely keeping the x first, and you'll see why based on this format. Well, now I have y being multiplied by 2. Well, that means I need to multiply everything by 2. I'm sorry, divide everything by 2. It's being multiplied, divide everything by 2. So now I have y equals negative 1/2 x, or negative x over 2, plus 7 over 2, or 3.5. So I could write it that way, or that way. They're equally good. Get my face out of your way. Okay. Equally good ways of writing this equation. And we will practice with this skill of isolating the y. Notice when that happens, I have a slope of negative 1/2. If you calculated this, it would show a slope of going downhill 1/2. Okay. It also says that it's going to cross the y-axis at 3.5. 1, 2, 3, not quite to 4. Oh, look, 0, 3.5. That is the y-intercept. So the entire thing I want you to take from this lesson, from the pieces that we're about to do as examples, is that finding the y-intercept is where the line crosses the y-axis, and this is where it fits in the equation. All right, well, let's take a look at some examples. So I'm going to Savvis. This is nothing new. Okay. And we're not going to spend a lot of time on part 1, only because part 1 is a lot about the tool and not a lot about finding the actual y-axis. I have to move me. Sorry, guys. All right. But let's take a look. So this asks us to graph the equation y equals x plus 3. There's nothing in front of the x, so that means our slope is 1 because it's an implied 1 in front of the x. The positive 3 means that our y-intercept is at 3. So we're just going to actually skip ahead real quick here and view this solution if I can. Let's see. There we go. And you will see we have a slope of 1. For every 1 it goes up, it goes over 1, up, over, and it crosses at 3. So that is the correct graph for that equation. Now, let's look at it in a little more practical way in part 2. In part 2, it's going to ask us to identify the y-intercept. So right here, if I look at this line, very steep positive slope, it looks like it crosses about -2. So let's give that a try. On this one, very steep negative slope, it looks like it crosses around +2. Let's give that a try. This is in the correct format. Y equals m, the slope, x, plus or minus a number. That is your y-intercept. So my y-intercept is -3. On this one, I'm going to have a negative slope. My y-intercept is +3. So that is literally what you're looking for, either on the graph, where does it cross, or in the equation, as long as it's in this format, what's in that B position. Well, let's give it a check. Cursor doesn't want to find it, but we are correct. All right. Now I want to do one with you. So we're going to go on to part 3. In part 3, we have a snowstorm. So we're going to wait for a minute for Savis for its snowstorm. Okay. But I want to look at the graph, and I want to look at the equation. So in this story, we have snow on the ground, and it's continuing to fall. It asks, what is the y-intercept, and what does the y-intercept represent? Well, there's where it crosses the y-axis, at the 3. Okay, and what does that represent? That means there were already 3 inches of snow on the ground when this storm started. Then it asks about the slope. Okay, and if we look here, the snow goes up 1 inch every 2 hours. 1 inch, 2 hours. Okay, so in this case, we have a rise of 1, a run of 2. Okay, rise of 1, run of 2. So here's how it looks on my paper. And this is just the graph paper that I kind of gave you guys that would be easy to work with. Small little graphs. We started at 3 inches of snow. We got to 4 inches in 2 hours. 5 inches in 4 hours. And it continues. And we can literally draw a line. Now, because this is snow, we're not going to go negative snow. Okay, we don't need to do that. So it's going to stay in this first quadrant of the graph. But because we have good graphing skills, we're going to go ahead and draw the graph showing the full slope and showing that it continues. Now, in real life, we know that a storm would stop. But if you notice, we have a slope here and we have a y-intercept here. That is how the graph and the equation and the story all combine. So go ahead and copy these down, do that work, and we will then move on to your try problems. Have a great day, everybody.